Hello everyone, welcome back to my channel. Please do not forget to like the video and subscribe to my channel. Today I'm going to present the introduction to supervised learning part 2, and let's discuss about the learning algorithm. The learning algorithm in the context of machine learning, let's denote the algorithm as capital A. It takes a data set and it tries to approximate a mapping function f hat, which this function is supposed to define a true dependency of f, which is unknown. So basically, the algorithm works in the space of the data set and it returns an approximation function. Here is an example of a very intuitive and a simple algorithm, which is k nearest neighbor, or in short, KNN. K defines the number of nearest neighbor, which the algorithm is supposed to consider in the process. So the idea of this algorithm is pretty simple. It says the closest object supposed to share similar characteristics, so as a result, similar targets. So basically, based on some distance metric that we define for the algorithm, this is a parameter. It based on what you define for the model to work based on which distance metric. So it's also a hyperparameter for the model to define. Based on those metric, defines the closest data point to the object of interest, and based on some method, it tries to aggregate those targets of those nearest neighbors, and it assigns the prediction to the object of interest. Here, for example, we have the approximation function, which takes an object of interest that I want to find the target for it. It looks into the k nearest neighbor and it puts those points into a set of data set, and it takes the average of the target value for them. Here, assumption is the task is regression, so it means the value of the target supposed to be a real value. And we simply take the average of them and we assign this target to the object of interest. Here is an illustration of how this model works. Here I have a theoretical true dependency. It's a toy example, that's why I know what is this dependency. And I have a set of 50 training data point that we show it by the blue dots. And the model try to estimate this mapping function, and the orange line is the prediction of the model by k equals to 3. It means for predicting each of the target, each of the value, the model looks into 3 nearest neighbors. So the result of this model, it's like a piecewise step function that you can see horizontal, vertical line. And how we can make this model more accurate, basically by adding more data point to our data set, because when we add more data point into training phase, we get more data closer to each other. We reduce the distance between two individual data points. That's why we get more smooth and more accurate line for our task. The k nearest neighbor can be also used for classification task. Classification task, it simply means for the target, we define a class of value. For example, here I'm separating the blue points from orange points. So the classes are blue or orange. How this model works here, I have a mapping function which takes an object of interest. So basically, the model tries to look into the k nearest data point and look into their classes and defines which class occur or appear more. And here is an indicator function. So basically, indicator function receives a condition. And if the condition is true, it returns 1. Here, the condition is true. And if the condition is false, it returns 0. So basically, it defines each of these target is equal to which class. Let's consider we are going to look into 8 nearest neighbors. And if I'm interested into any data point here, with considering 8 nearest neighbor, let's assume I have 5 data point with orange classes and 3 data point with blue classes. So in this case, the model predicts the target as orange for this object of interest because the orange appear 5 times against 3 times with blue points. As for the plot, this is a classification task. The blue points are in the left side, the orange point on the right side, and this black line, which is the border between these two classes, defines the border of these classes from one class switching to another class would be this border line, basically. And if we consider k neighbors as 1, it means each data point would be considered by one nearest neighbor. So here the model will be overfitted and the border is rather strange because if I want to define the class for orange, there's no data point, only himself. So the border would be this strange border in the heart of the blue points. And the model will have 100% accuracy on the training set, but of course it has a lot of error in the test set because the model is not very generalized and it's overfitted on the data. We will discuss about overfitting and generalization later. But if I consider 10 nearest neighbors for this task, I will get more reasonable separating line between two classes. Of course, it's always a trade-off between losing some accuracy, adding more error, but generalization, because I'm misclassifying some of the data point. They are orange, but I classifying them as blue point. And this is based on the assumption these data points might be an outlier. So it's better to put them as error. And then in future, when the new data point for test data set comes, and if the new data point is here, I'm more likely supposed to define it as a class blue because there are mostly blue points here. So how this model tries to find this approximation f hat. So the majority of the algorithm, they try to solve an optimization tasks. So here we have a loss function that we want to minimize this loss function. So the optimization appear in this sense. A loss function with capital L basically takes the true target yi, which comes from the true dependency, true target, and it takes the prediction of the model, this mapping. And by some metric, it tries to find a single value for the loss function. So in terms of regression task, we can name the S-squared error as the loss function. What is it? Basically taking the S-squared of difference between, for example, the true and the prediction. So we are squaring it because we don't want the positive and minus values cancel out each other. But actually, we are not interested into a single value error, but rather the expected or average error. So the approximation of this function comes out of the expected minimization of this loss function. As a last model I want to present here is a linear regression. It's also simple and intuitive and really understandable. This model says the target's supposed to be the linear combination of the input features. So f hat of w and b of x, this is the object of interest for prediction, it would be w transpose x plus b. B here is a bias term, or sometimes we call it as intercept. And w is the coefficient, which is multiplied by each of those value of x, which defines the slope of line or plane or hyperplane. And b basically, which is the bias term or intercept, defines if this component is 0, the start point of this line or plane supposed to start from which data. And this type of model tries to optimize a loss function. One of the very widely used one is mean squared error, or MSE loss in short, which takes the average, n is the number of data point that we are considering, the average of sum of the difference between the true value with the prediction to the power of 2, and we want to minimize such a loss function with respect to the coefficients W and the bias term, because only W and B can be optimized to get a best mapping function, because X is constant and which comes from the dataset. And in this plot, we can see a 3D plot of showing this type of task. I have X1 and X2 with a target. So because I have a 3D plot here, we are not dealing with a line, but rather with a plane. And all the predictions falls on this plane, these black dots. And the training points are blue points, and these distances are denoted as these red lines between the prediction and the true ones. And we want to minimize sum of S squared of all of these errors together. So to find the W and B, which gives me the best plane on this plot. Thank you for watching this episode of the tutorial.